Okay, next we're going to jump into synthetic division. So, if you take a number like 8, we're able to break this up. And we know from experience this is 2 times 2 times 2. But to get there, what we do normally is we divide by 2 and get 4 as the other part. And then we divide that 4 into 2 and 2. So we know that 2 times 2 times 2 is 8. And it actually doesn't matter which order you divide it up. As long as you keep dividing, you're going to get down to these unbreakdownable numbers. It's the same with polynomial expressions. So for like this, we know one way to break this down. We could factor. We think about pairs that go into 3 and add up to 4. And we could break this down into x plus 1 and x plus 3. And so we write it x plus 1 and x plus 3 equals x squared plus 4x plus 3, the whole thing. Okay, and so one thing that you'll learn here in these chapters is that when there's a second degree power, we're going to have 2 things that we can break it down to be. Alright, so this was factoring. And we learned a trick to do that. We learned a special way to kind of undo that expanding and get that factoring down. We're going to learn another trick that will help us speedily long divide. So it's called synthetic division. Now there is something, if you look it up, it's called polynomial long division. And it is a legal way of long dividing. But synthetic division is faster, so I'm not going to be showing long division here. I'm just going to be synthetic dividing. So what they'll give you is they'll give you something like x squared plus 5x plus 4, and we want to divide by x plus 4. So it's kind of like 8 divided by 4. We should just get one chunk right there. Or we should divide it out and get what's left over. So this is how we do it. We take the coefficients and we write them here. The number in front of x is 1. The number here is 5. And this is 4. And for this to work, you have to think about the root, or the intercept here. So the intercept here is -4. By the way, when that graph touches at 1, 2, 3, 4, that is called an intercept or a root. So I might use the word root as well. So that -4 is what we put right here. Now here's the process. I will do this in blue. This drops down. And then this means multiply. So -4 times 1 is -4. When you come down, you're going to be adding. So 5 plus -4 is 1. And then we swing around. So this is going to be times. -4 times 1 is -4. And you add down. 0 here. Okay. So we have to interpret this now. 1, 1, and 0. Normally the 0 is sectioned off here, because the last number is called the remainder. So I don't know if you remember long dividing, but if you try to put 7 in 24 and you do 3, 3 times 7 is 21, there's a 3 there. That is the remainder, because 7 can't divide evenly into it. So in this case, there is no remainder. It's divided evenly. And now there's 2 ways to write this. We could say that x squared plus 5x plus 4 divided by x plus 4 is this. Now that doesn't look like a polynomial, but if you were to think of this as the number at the end, and this as the number next, this would be 1x plus 1. And that is our answer. It's 1x plus 1. Now the other way to write this now if that divided by that gives you this answer, this times that should give you this. So the other way that we write this is x plus 4 times x plus 1 equals what we started with. Now this just looks like we had factored, but we used it a different way. So let's do another example here. Except now we are going to do a little larger example. We're going to do a cubic example. So they have us take x cubed and divide by x minus 3. Okay, so the way we do this again is to start by writing down the coefficients 1, 1, negative 24, 36. And then we think of the root or the x-intercept that goes with this, which would be 3. And that 3 is what goes here. I drop my 1 down, and then I start to multiply. 3 times 1 is 3. Then I add down 4. 3 times 4 is 12. And then I add down. 3 times that is negative 36. And if I add down the last column, I have a remainder of 0. Now, to translate this answer into a polynomial, this would be a negative 12. This would be a 4x, and this would be a 1x squared. So this is the answer. X squared plus 4x minus 12. But also, the other way we could write this is we could take the original polynomial and we could write it as x minus 3 times this. So if we were to FOIL out the right side here, we would get that by expanding. And going this way, we long divided, or we factored. So now we're taking what we did from quadratics, we are taking it up a level, now we're doing it with cubics. So I have one more warning about this though. We have to be careful about one thing. For our class, when we do this, you might encounter x cubed minus 21x plus 20. And we want to divide out, we want to factor this out by long division. And they will tell you to divide by x plus 5. Okay, now the one thing about this is, if you were to look at the x squared terms, there is none. So when we are factoring this, we need to put a 1 here, and for the x squared, we need to include a 0 placeholder, and then we put negative 21, and we put 20. The root for x plus 5 is negative 5, so that goes here. So that's just the thing that you might miss, and if it's not coming out, maybe you should check, did I miss any of those x squareds or x's that aren't in the original, because I need a placeholder. So I drop down the 1, negative 5, add down to get negative 5, times to get 25. That would be 4 and negative 20. So my answer here is x squared minus 5x plus 4. Or the other way to write it, that is the same as x plus 5 times this right here.